Okay, so we have a few more definitions that we got to cover today before we can do our work. So the first one that I want to look at is an inscribed angle. And so that's what basically all we're going to be doing today, are inscribed angles. So an inscribed angle is an angle whose vertex is on the circle and whose sides contain chords. So what that would look like is if I drew two chords that met at a point on the circle, that would be an inscribed angle. So their vertex, where they meet, is on the circle, but also the other two edges. So if I labeled each point A, B, and E, I would write this inscribed angle just like I would label any other inscribed angle. So this would be angle A, B, E, or you can write it the opposite way, angle E, B, A. Now, when we start solving, you're going to need to know the formula that our inscribed angle, which is this angle right here, so our angle is going to be equal to half of whatever our arc is. And here it says intercepted arc, but we're about to talk about what that is. So an intercepted arc consists of the endpoints that lie on the inside of the inscribed angle and all the points in between. So if I was to draw the same inscribed angle, and label it A, B, E, my intercepted arc would be this arc between A and E that the inscribed angle is across from. And so we learned yesterday how to write an arc, and so that is just the arc symbol, and then this one would be A, E. Okay? Could it be EA? Yes, it could. Okay. Now, my intercepted arc is always going to be 2 times whatever my angle is. So it's the opposite of this. Up here it was the angle is half of the intercepted arc. Down here the arc is 2 times the inscribed angle. And so we're going to use that some more in our notes. So flip to your second sheet. Okay, yesterday we talked about central angles. So the central angle is located where in the circle? In the center. So this would be our central angle. And how does it correspond with the arc across from it? It's equal. So our central angle is always equal to whatever our arc measure is. So let's say our arc here was 84 degrees. What would angle ACB equal then? 84. Okay. Now, our central angle came from the center. Our inscribed angle is sitting where on the circle? On the circle, on the arc. So here's my inscribed angle. It's still across from this arc, okay? And then the relationship that it has is that my angle is always going to be half of my arc. So angle equals half of the arc. So let's say again that this arc AB is 84. Or its arc measure is 84. What would angle ACB be? What'd you say, Eric?
I said 42.
42. Very good. Is that simple enough? Okay. All right, well then let's try a couple of these. Let's look at number 1. In number 1, what type of angle is ACB? A central angle. So what does that mean that arc AB would equal? 120. Okay. What about here? It asks about arc XYZ. So I have to go from X to Y all the way around to Z. How would I find that? Oh, and it's not labeled on your sheet. This should be 120 degrees. So how would I find this arc? Yes. So we would subtract 120 from 360. So that arc measure would be 240. Okay. And then number 4, they ask us from C, the arc measure from C to E. Does anybody have a thought of how we would do that one? Nope, can't do that. What do you think, Maggie? Okay. A quicker way to do that is we do know that this is 180, so that's a good thought. What's the only piece we don't want out of that 180? What piece do we not need? 47. So we could do 180 minus 47 so that we can get this whole piece. And so that would give us 133. The way you would have done it would have worked, so that's a good way of thinking about it. The way that you said it would have worked, yes. Okay. Now let's look at some inscribed angles. So in number 5, we're looking for angle ABC, which is this angle right here. How would I go about finding that? Okay. You either half it or multiply by 1/2. So half of 124 gives us 62. So ABC would be 62 degrees. Okay, let's look at PQ. So for PQ, they give me angle PLQ, which is 88, and they want me to find my arc measure. So how does that? You would multiply by 2. We're not dividing this time because we're going from angle to arc. Arc is bigger. To find what? To find the arc, you'd have to multiply. Yeah?
Yeah, but you don't have one. You don't start with one.
Okay. Yes, John, that would work. I would not necessarily do it that way, but it works. Okay, so we got 176. All right, next. These look a little bit harder, but they're not too terribly harder. So let's look at number 9. In number 9, they ask us to find XYZ. So angle XYZ is located right here. The arc measure that it's across from is XZ, but we don't actually have a value for XZ. So how would we find that?
Oh, okay. Since ZY is since ZXY, W is a semicircle,
Mm-hmm.
half, it goes to 180, and then you do 180 minus 110, 180 minus 110, and that's how much that's like.
Very good. So this is a semicircle. So we can do 110, which is what this is, subtracted from 180 to find what's left for this, and that is 70. Now to find that angle, what would I have to do to 70? Divide by 2. So our answer would be 35 degrees. Okay. Let's look at number 10. So in number 10, it asked me to find BLU. So angle BLU is right here. What arc is that across from?
114.
Okay, it's across from arc measure 114. So what would we do to 114 to find that? You'd half it, and that would give you 57. Okay. Next, we want to find LE. So arc measure LE. What angle is that across from? 28. So you'd multiply that by 2, which would give us 56 degrees. Okay? Pretty easy so far, right? All right, let's look at 12. So in 12, they want us to find measure X, Y, Z. So that's this measure right here. What type of angle is this right here that they want us to find? It's inscribed. And the angle they give us, XWZ, which is 110, what type of angle is this? The central. What do we know about the central and the arc measure? They're equal. So that means this arc measure right here is 110. Now, if I'm looking at this inscribed angle, doesn't it go to the same arc measure? So how could I find this inscribed angle right here? You take 110, divide it by 2, because remember our inscribed angle is half of the arc it's across from, and that would give us 55 degrees. Any questions so far? Okay. So on 13, they want us to find measure AC, arc measure AC, and they give us arc measure ABC. So this whole piece right here is 214. Can you tell me how we would find the missing piece? No. What should a circle add to be the measure of a circle? 360. So we'd subtract 214 from 360, and that would give us 146 degrees. Okay. Then in 14, they want us to find X, Y, Z. So I'm looking for this angle here, and they give me arc measure X, Y, Z. So if I go from X to Y all the way around to Z, that is going to be 244. So the only way I can find this measure is if I know this arc measure across from it. So how do I find the missing arc measure? Subtract from 360. So we do 360 minus 244, and that gives us 116. So if this piece is 116, how would we find? You divide it by 2, because we just found the outside. Now we're finding the inside. So to find the inside, we divide by 2, and that gives us 58 degrees. Okay. Flip, if there are no questions, flip to the back of that sheet. Okay, so things that you need to know about inscribed angles. The first one is that two inscribed angles that intercept the same arc are always going to be equal. Okay, so let me show you what that looks like. Let's look at number 1 right here. They want us to find RST. So RST is right here, and it's across from this arc, right? Okay. We also have a second inscribed angle. The second inscribed angle is 64. And 64 is across from what arc measure?
Same one.
The same one. So that means that these measures would be equal. So angle RST would also be 64. That's all that means. Yes, if they both go to the same arc measure, they're equal. Number two, actually, number two you don't have to do like that, but we'll get there. Now, the second thing that I want you to know is that an angle inscribed in a semicircle is always a right angle. So an example of that is like number 4. Can everybody see we have this diameter here, or this piece of the triangle that cuts this into a semicircle? So if this angle is inscribed in half of a circle, see how the angle ends at the half circle? Then that means that it's going to have a right angle. And so to solve for x here, since this angle is x squared plus 9, and we know it's 90, we'd set it up as x squared plus 9 equals 90. To solve for x squared, we'd subtract 9. That'd give us x squared equals 81. Then we would take the square root, and x would equal 9. Does that make sense? So in all of these, 5 through 7, all of these angles are within a semicircle. So there's going to be a 90-degree angle in them. Now, the last thing that I want you to know is that if a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. Yes. So if you remember, that means they add to 180. Okay? Do we remember what a quadrilateral is? Yes, it's a shape with 4 sides. Okay? And so we'll talk about, I'll show you an example of that in just a moment. Let's look at number 2 before we move on. So in number 2, they want me to find angle LMN. So angle LMN is right here. What arc measure is that across from? 68. So how would I find this here? Divide that by 2. And so this would equal 34. All right, let's look at 3 now. So in 3, they ask us to find 2 measures. One is angle WIT. So we're looking for this angle here. What type of angle is that? Is it central or inscribed? It's inscribed. Okay. And so we're looking for the arc measure across from it. What arc measure is across from it? 48y. Okay, there's supposed to be a y here. That's why there's a big space. So how do I know, or what relationship do these two have? What do we know about the arc and the measure? Okay, the arc is half of the angle, or the angle's half of the arc. So if we did, or let's say 2 times the angle equals arc. Does that work? So 2 times our angle, which is 3y squared, should equal our arc. So if I multiply this, that gives me 6y squared equals 48y. Okay. One of my classes wanted to divide both sides by 6 and both sides by y. You can do it that way, or you can also factor by GCF. Which one is easier for you guys? Okay, so if we divide both sides by 6y, these 6's cancel, then I'm left with 1y equals, these y's cancel, and what's 48 divided by 6? 8. And so my y equals 8, but to find this angle, I need to plug it into what?
3y squared.
So 3 times 8 squared. And that gives us 192 degrees. Very good. The second thing they asked me to find is arc measure IE. So this arc measure right here. What angle is this arc measure across from? 3x minus 4. What else? 6x minus 22. So what does it mean about these two angles? They're equal. So what do you think we'd do with those two equations? You'd set them equal. So that gives us 3x minus 4 equals 6x minus 22. I could subtract 3x from both sides, and that would give me 3x equals, add 22 to both sides, and that'd be 18. We divide by 3. X would equal 6. So if I plugged 6 back in here, that would give me 3 times 6 minus 4. We know 3 times 6 is 18, minus 4, 14. So my angle measure is 14, which makes this arc measure what? 28. Very good. Okay, let's try one more of the semicircle ones, and then we'll move on to quadrilaterals. Okay, so in number 5, we see our semicircle. We see that our angle is within it. So where would my 90 degrees be? On the R. So what do I know about all the angles in a triangle? They should add to equal to 180. So we could do 7y plus 11 plus 3y minus 1 plus 90 equals 180. If I combine my like terms, that's going to give me 10y plus 100 equals 180. I'd move my 100 over, which would give me 10y equals 80. Divide by 10, and y equals 8. Any questions on those? Okay. I think your favorite is going to be the quadrilaterals because it's the easiest. So what did it say about the quadrilaterals a few minutes ago? If it's inscribed in a circle, opposite angles are supplementary. So that, what is opposite of 78? P. So to find P, I do 180 minus 78, and angle P would be 102. Then what angle is opposite of L? Q. And so we would do 180 minus 82, and angle Q would equal 98.